Hi, and welcome to Mrs. Ballard's class. Today we're going to be talking about calculus topic 1.16. And we're going to be working with the intermediate value theorem. So this is something kind of totally off the topic of what we've been doing the rest of the unit, but this is the first place where it fits in, and we will revisit it again later in the curriculum. The lesson objectives, or the essential question, is how do we apply the intermediate value theorem? And then you're going to write down actually two I can statements today. I can apply the intermediate value theorem to find a zero, and I can apply the intermediate value theorem to find a C value, and that's going to make more sense when we actually do it. As always, if you need to pause for some extra time to write things down, that's fine, or you can always rewind if I go a little too fast. Okay, let's go ahead and take a look at this. All right, here we go. All right, if you have not read through this first activity, so my suggestion is you take a few minutes and you read through that activity right there and you try it. So I pause, and it might take you like 5 minutes or so. Give it a good 5 to 8 minutes of reading through those problems and answering those questions. It really isn't that difficult. I'm going to pause for just a minute, and then I'm going to start kind of talking through that right there. So as always, we want to make sure that we have written our name on here. So just make sure that you've added your name up to the top there. And I'm going to do something a little bit different today. I am going to try to type some of my answers here. It's not liking it because I'm using the pen instead of the cursor. All right, so the activity here talks about being an Uber driver. So Uber is a ride-sharing service operated by 785 metropolitan areas worldwide. Their mission is to make transportation accessible to everyone. You would have just begun employment as an Uber driver in New York City. So I'm sorry, I did not change the example for California, so we're going with New York City. What are some things you have to think of as an Uber driver? So some things that you could have possibly come up with, maybe you have to think about paying for gas, insurance, maybe who you're picking up, the route you have to travel, maybe traffic, speed, you have to pay for maintenance on your car. Okay, so those are just some of the things. There's probably plenty of others. Those are just a couple ones that I brainstormed. All right. When you pick up your first group of tourists, your odometer reads 0 miles. I, of course, spelled this wrong. Does it give me a choice? No. Nope. All right. It reads 0 miles. So this right here would be considered your Y value. Okay. When you drop them off at the Statue of Liberty 40 minutes later, so 40 minutes, the miles is the Y value, the minutes is the X value. It reads 17.5 miles. Must there have been a time during the trip when your odometer read 8 miles? Well, if we think about that, is there any way that I could have possibly skipped over the number 8 when I go from 0 miles to 17.5 miles? And there isn't a way to do that. So must there have been a time during the trip when you read 8 miles? So the answer is yes. You can't skip 8 miles and get to 17.5 miles on the odometer. Now, a little side note on that, okay? So this is something else. If you wrote that down already, this is something else you probably want to add to it. The distance is a continuous function. So 8 is guaranteed on the odometer between 0 and, let me try to write that, between 0 and 17.5 miles. I don't know if it'll let me change the color. Let's try. There we go. I'm just going to go with my misspelled maintenance word. In fact, I want to change this to something totally different because this is kind of like my commentary on it, huh? All right. Probably can't read that now. All right. So at 3 p.m., you were hired by a group of teachers to take them from Long Island to MoMA, the Museum of Modern Art, which are 50 miles apart. You drop them off at 4 p.m. So is it possible that at some point on the trip you were 53 miles away from MoMA? Explain. So what do you guys think about that? If you had to have taken an alternate route, which may have gotten you there faster because of traffic, it is possible. So yes, it's possible because you may have taken an alternate route. Okay. And then a little bit of commentary on that is that you aren't necessarily guaranteed to be in this interval. So you're not guaranteed because the 50 or the 53 is outside. Oh, never mind. Don't listen to me yet. Let's do B, and then we'll make the commentary on this one. Must there have been a time when you were 53 miles from MoMA? So did you have to do that? And the answer is no, right? You could have gone straight there. So my extra little addition to this is that 53 miles isn't guaranteed. You are guaranteed everything between 0 and 50, but not 53. So 53 miles, not guaranteed distance on our interval from 0 to 50. Okay, I could highlight that and make it pretty colors too. I'm going to start with blue, and then the green, the green. With the pretty green from down there. There we go. Okay, and then finally, during your 8-hour shift, you made 12 Uber trips. Your first trip has 2 passengers and your last trip had 4 passengers. Should we assume that one of your trips had 3 passengers? Explain. Well, the passengers aren't guaranteed in between things. So that's not, the number of passengers isn't a guaranteed item. So I would say no. The number of passengers isn't guaranteed. And then my little commentary is that the number of passengers is not a function of time. And not continuous. So we can't predict it. All right. Let's see. No, continuous. There we go. Okay, so this. That one's green. This one's blue. All right, so basically what that little example was to show you is that this is an illustration of what we call the intermediate value theorem. In layman's terms, the intermediate value theorem basically means that as long as our function's continuous and we have a closed interval, we are guaranteed all those y values within that interval, okay? as long as we have that happening. So these were some examples. The odometer was an example of the intermediate value theorem because it's got to be continuous and you can't skip over the miles. Okay. But you have to be, we also saw the example here where you 53 miles, you could do it, but it isn't guaranteed. The guaranteed distance is between 0 and 50. All right, so let's actually formally write our intermediate value theorem out here. So I'm going to flip my computer a little bit here now that I'm not typing. And it's going to feel like English class today. There's a lot more English writing today. So one of the first important existence theorems we will study in calculus is called the intermediate value theorem. Like all existence theorems, we will study the IVT relies on the continuity of a function, and that's super important for our function to be continuous. So if f is continuous, and that is so important that I would make sure I highlighted, bold, starred that word, okay? On a closed interval from a to b, and k is any number between f of a and f of b. So basically it's saying that these are the x values here, then this other number here is some number that's between these y values. So those are the y's right there. There is at least one number c in a and b such that the y value, the f of c equals that number k that's between these two y values. And you can kind of see the picture illustrated here. I know we did a kind of an example, but basically if I have these two x values, a and b, and my function is continuous, I know that I have to cross this y value right here at some point if I'm going to be between these two values. And you'll notice here that doesn't work because the function is not continuous. All right, so let's go ahead and try some of these examples. We've got the function f of x is continuous on the interval from -3 to 9 with f of -3 equal to 0 and f of 9 equal to 12. Which of the following could be a correct statement concerning the existence of a value c by the intermediate value theorem for the function f of x? Well, first of all, we know that f of x is continuous, so f of x is continuous. That guarantees that the intermediate value theorem works. Let me rewrite that a little bit there. So I would write, therefore, by the intermediate value theorem, it guarantees a value c on 3 to 9 such that it's between the two y values. Well, they gave us two y values, didn't they? Such that 0 is less than or equal to f of c is less than or equal to -12. I don't think that is in the right order, do you? So I think that it should actually be the other way around. It should be from -12 to 0. So I have to figure out a number that's between -12 and 0. So if I'm looking at these y values here, I'm looking at 0, which is not necessarily between, okay? 13 is, -13 is definitely not between. -10 is, and and 1 is not between. So those ones are out. So what's the difference between A and C? Because A is kind of in the interval, but it's on the edge. But let's look at the x values now. So do you see how this x value, the x values we had to be between were -3 and 9. And do you see how the 12 is not in between those values? So that means that that's the reason that that one's out. So it's got to be answer choice C. All right, so now we're going to use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 on the interval from 0 to 1. So whenever you do these problems, the first thing you need to do is state that the function is continuous, and it should be. If it's not continuous, then you cannot use the intermediate value theorem on this. So we know that this is a polynomial, so it's continuous because it's a polynomial. So you just say f of x is continuous. And you can even say, since f of x is continuous, the IVT guarantees. We're going to kind of have a sentence frame that we're going to get really good at. Guarantees at least one c-value on the interval from 0 to 1. And really what's going on with that is that it changes signs on either side of c, so such that f of x changes signs on either side of that c. Okay, so we're supposed to be showing that we have a 0 here. So what I really need to do is I need to calculate what these values, the y values are that match these x values, and the interval is always in x values. Okay, so I'm going to do those calculations. So f of 0 equals 0 cubed plus 2 times 0 minus 1, which is -1. And f of 1 equals 1 cubed plus 2 times 1 minus 1. So these 1's are going to cancel, so we would get 2. And notice that 0 is actually between those, so we're going to make that statement. So we know that we've got f of 0 equals -1 is less than 0 is less than f of 1 equals 2. So therefore f of c, equals 0. So therefore there must be a c such that f of c equals 0. All right, let's take a look at another one here. Okay, so we are supposed to explain why the function has a 0 in the given interval. So the very first thing you want to do is state that if your function is continuous. Again, we have a polynomial in example 3, so I'm going to state that it's continuous. So since f of x is continuous, the intermediate value theorem applies. Okay, and then, or continuous, I really should have written the interval, continuous on 0, 1. And then I really should do this calculation here and put these x values in and see what the y values are to see if I have, because again, we're looking for a 0. So f of 0 equals 0 cubed plus 3 times 0 minus 2, which is going to be -2. And f of 1, is this the same problem? Nope, it's a slightly different problem. Okay, f of 1 equals 1 cubed plus 3 times 1 minus 2. So let's see, 3 plus 1 is 4, minus 2 is 2. So basically, is 0 in between those? Absolutely. So now we need to make that statement. Sorry. So IVT, and so you could go ahead that IVT guarantees. I don't like the way I'm writing that. Let me fix that up. Let's add this stuff in first. Okay, so let's say that f of 0 equals -2 is less than f of c equals 0 is less than, not less than or equal to, f of 1 equals 2. Therefore, IVT guarantees at least one c value such that f of c or x equals 0.